All right, so when you hear blockchain, you probably think cryptocurrency, right? But what if I told you that's just scratching the surface? What if it's a whole new way to build, well, pretty much anything automated? Today, we're going to go way beyond just money and see how simple lines of code can grow into contracts, apps, and even entire companies.
So let's start with this. Just chew on this for a second. What if an agreement could literally enforce itself? No lawyers, no courts, no middlemen. Just code. This one idea, this one question, is really the key to understanding everything else we're about to talk about.
And that's where we get to the absolute bedrock of this whole new world, the self-executing agreement. You can think of it as the basic atom, the single Lego brick that everything else is built from. So what exactly is a smart contract? At its heart, it's just a piece of code that says, if this happens, then do that. The classic example, and it's a great one, is a vending machine. It's a dumb machine, right? But it follows a strict rule. If you put in the right amount of money, then it will give you a soda. No questions asked. A smart contract is basically that, but for anything digital. It's code that automatically and enforceably handles a transaction.
Okay, so when you put it side by side with a traditional contract, the difference is, well, it's huge. Your typical legal contract relies on the legal system, on people, on trust. It's slow, it's expensive. A smart contract? It's all about the code. Enforcement isn't up for debate. It just happens. You're not trusting a person. You're trusting that the code will do exactly what it says it will do.
And look, this is way more than just a cool tech trick. It's a total economic shift. When you cut out the middleman and automate the rules, the cost of doing business plummets. All of a sudden, you can have people and businesses interacting directly, peer-to-peer, in a way that was just way too complex or expensive before.
All right, so if a smart contract is like one single Lego brick, what happens when you start snapping a bunch of them together? Well, you can build a house. And that's exactly what a decentralized application, or a DApp, really is.
So, a DApp. It's basically a website or an app that looks and feels normal on the front end, but the magic is in the back end. Instead of running on a company's private servers, like Google's or Amazon's, it runs on a peer-to-peer blockchain network. It lives everywhere and nowhere at the same time, which makes it super resilient.
And this is where you really see the core difference. With a regular app, one company holds all the cards. They can shut it down, they can censor you, they control your data. A DApp flips that script entirely. No single person or company is in charge, which makes it resistant to censorship. And all the transactions, they're out in the open, recorded forever on that immutable ledger.
Okay, so you might be wondering, how do you actually use these DApps? A lot of them are powered by tokens, and the ERC20 standard on Ethereum is like a universal plug. It's a template that makes it super easy for developers to create their own tokens that all work together. Think of them as the fuel or the currency that makes the DApps economy go round.
Okay, so we've gone from a single contract to a whole application. You can probably see where this is going, right? What's the next step up? It's not just a decentralized app. It's a decentralized organization.
This is where things get really wild. A DAO, or a decentralized autonomous organization, is basically an entire company run by code. The rules, the voting, the treasury, it's all managed by smart contracts. There's no CEO calling the shots, there's no board of directors. It's the community of token holders who collectively make the decisions.
And when you compare it to a traditional company, it's just a night and day difference. Companies are hierarchical, top-down. DAOs are flat. It's all about community governance. And the transparency? Forget about it. A company's books might be a secret, but a DAO's treasury is completely open and auditable by anyone on the blockchain. It's a radical experiment in governance.
So how does the code actually pull this off? How does it enforce all these rules? Let's pop the hood for just a second and look at a couple of key tools that make these systems tick. First, we have something called a modifier. The best way to think about this is like a bouncer at a club. Before a function can run, the modifier checks your ID. It asks, are you on the list? Are you old enough? In code, that could be, is this person the owner of the contract? If the check passes, you're in. If not, the function is blocked. It's a really clean way to handle permissions.
And then you've got the fallback function. This is kind of like the contract's catch-all department. Let's say you send crypto to a contract, but you don't specify which function to call. What happens? The fallback function kicks in and decides what to do. It's a safety net to handle unexpected or generic interactions. Okay, so this all sounds amazing, right? Code is law, everything's automated. But there's a huge flip side. This whole system is built on code that's supposed to be permanent. So what happens if there's a bug in that unchangeable code? And this quote just hits the nail on the head. Immutability, the fact that you can't change the code once it's deployed, is a double-edged sword. It's what makes the system secure and trustworthy, but it's also what makes fixing a mistake an absolute nightmare.
And this can't-fix-it problem opens the door for some serious security issues. You've got things like a 51% attack, where someone with enough computing power can literally rewrite the blockchain's recent history, or a replay attack, where a hacker just copies and pastes a valid transaction over and over to drain an account. And then there are Sybil attacks, where one person creates a ton of fake identities to overwhelm a voting system. The blockchain might be secure, but the apps built on top of it, they can have very real vulnerabilities.
And that really brings us to the big, thorny question at the end of all this. As we hand over more and more power to autonomous code, who's on the hook when it all goes wrong? When a bug drains millions of dollars, who's responsible? The person who wrote the code? The people who used it? Or is it just no one? That's the huge challenge we have to grapple with as we build out this new world.